Hi friends, welcome to the Plain Fun RC channel, and I'm your host, Saul, and we are continuing with the AMTN Burt Rutan Beechcraft Starship build, and we're getting to the last little bits and pieces, specifically installation of the radio. So I want to take a moment and talk to you about the servo choices. Now, in the manual, it recommends going with this particular servo here, the Hi-Tech HS5087MH. It is a high voltage servo, and you can see on the back with regards to the torque that it generates and the size. At 7.4 volts, you're looking at approximately about 59.7 ounces or 4.3 kilograms. Now, it's a fine servo. It's a great servo. The problem is that it's not very thin. It will fit in here, but you won't be able to put a servo hatch over top of the wing. In the instruction manual, it actually shows using this servo and then covering the servo with just regular covering. Well, I'm not a fan of that for one simple reason. If you're at the field or maybe you're out at a fly-in and you need to replace the servo, you have to then cut the covering off, put the servo in, and you've got to be able to find a way of recovering the area. So after doing a little research, Hi-Tech just came out with this new servo. It's one of their thin wing servos, and they have a couple different thin wings, and they're great servos. I've used them before. But what's so nice about this, it's a wide voltage servo, and let me take a moment to show you the incredible amount of torque that this generates. If you see there, we're going to be running 7.4 volts. You can see it's an incredible 83.783 ounces or 6 kilograms, which is crazy for such a thin servo. And one of the nice things about it, it comes with its own mounting block, and it's already pre-drilled for the holders here for the servo. So all you got to do is just take it and just drop it right in to the actual plate itself. And there you go, and that's it. And then you've got a couple spots here, and here, and here, and then here, where you can drill some holes to go ahead and mount it to the actual surface that you're going to mount it to. Now, initially, I was going to mount it to the actual servo plate itself on this side, but after going through and kind of playing with it a little bit, I'm finding it's easier to mount to the actual plywood plate, which was the original intent of the kit, so that you could mount this servo directly to the plywood plate. Now, there's only one small problem. The actual opening for the Canard on the front of the on the Canard itself is actually a little narrower than the actual opening here for the wing. So that's going to be a bit of a problem. We're probably going to wind up having to go with this servo here, and we may actually wind up having to use covering to actually cover it as well, which is rather disappointing. But nonetheless, we'll cross that path when we get to it. So for right now, we're going to go ahead. We're going to mount our servo here. We're going to put a couple of hard points here, and probably over here somewhere, so that we can go ahead and hold our servo plate in place. All right, friends, more to come. All right, friends, you can see we've got our servo plate cover mounting blocks in place. They're 1/4 inch spruce. We just used a little CA to help hold them in place, and they worked great. Now, what we also did to simplify the installation of the servo, instead of using the little black screws that come with the servo to go ahead and hold the servo in place and then drill extra holes here in the plastic mounting plate, I realized it's simpler just to go ahead and use 3/8 inch servo mounting screws, and then that way they're long enough to go through the plastic mounting plate and down into the plywood plate, and it holds the servo in place perfectly. So, simplifies the installation, and now we're going to go ahead and focus on putting our control horn on the aileron and getting our push rod in place. More to come. All right, friends, we're looking at the bottom left wing because I finished up the bottom right wing. Let's talk about what we've got here. We've got our servo plate mounted. We've got our slot cut for our servo arm. The width of the slot is just a little bit wider than the thickness of the servo arm itself, and the length matches that of the travel of the actual servo arm. Now, let's talk about the horn. The horn is made from the fiberglass plate. This particular horn comes with the actual kit. It comes pre-drilled for the holes here and also the hole for the actual clevis itself. Now, when you're determining placement from the leading edge of the aileron to where the slot where it needs to be placed for the horn, you want to make sure that the center at the hole here lines up with the hinge line, as you can see here, between the trailing edge of the wing and the leading edge of the aileron. That determines proper distance. Now, in terms of alignment, you could just take something as simple as a straight ruler or straight edge, put it right up against the actual servo arm itself, and then go ahead and draw a line on one side and do the same exact thing on the other side, and that determines proper alignment, so it's perfectly in line with the servo arm. And then I used a tiny Dremel tool to cut the slot, And you don't need it any wider than this part right here where you see the 4 little holes. And you just use epoxy, and that's it. So now we just need to go ahead and seal up the gap with some clear Monocoat right in here on both sides, top and bottom, and add our push rod, and our wings are completely finished. All right, friends, more to come. All right, friends, you can see we've got our push rod hooked up on our left wing. You're going to need to use a 256 rod with a 256 clevis and use a Z-bend on one end. The push rod's very short, and you can see in relation to my fingernail, it's not much longer than my fingernail. It's very short, so you don't have to worry about the push rod flexing since we're only using a 256. But she works great. Look at that. Perfect. All right, friends, we're going to go ahead and do the right wing, and more to come. All right, friends, as we continue our update, you can see we've gone ahead and we've put in our gap seal here. It's very straightforward. Just go ahead and cut a 1/2-inch piece and then take it and fold it in half lengthwise all the way down and just tuck it in the groove. Now, before you go through and you seal it, make sure the control surface is deflected in the opposite direction that you're trying to seal the gap. Once you have the piece in place, then take your trim seal tool here from hanger 9, go ahead and tack it to the trailing edge of the wing and the leading edge of the aileron, and that's it. That's all you have to do. One of the nice things about it is that by having your gap sealed, it decreases flutter, it increases lift, decreases drag, and in a worst case scenario, if for some reason your hinges fail, it actually helps to reinforce the hinge here and keep the control surface in place until you can land the aircraft. So it's a very important thing to add. More to come. All right, friends, as we continue our update, you're looking at the steering servo that's been installed. It is the high-tech HS5087MH high torque, high voltage servo. It puts out almost 60 ounces of torque, which is fantastic for such a small servo. It also includes these little side mount pieces here, which just snap right onto the servo and makes mounting the servo on its side very easy. Now, we place the servo between the formers. These lines represent the position of the formers that make up the hatch, and you can see the formers that I'm referring to here that are on the hatch. The thing you need to keep in mind is when you go and you're going to mount your push rod, make sure your landing gear is fully extended. And the reason for that is because if you look right there, you'll see your steering arm that connects to the actual landing gear. Notice how it slides up and down. What that does is as the landing gear retracts, this slides, and that helps to prevent any pressure being exerted along the push rod back to the servo itself. So do keep that in mind. One thing we also did too, you can see our hard points here that we put in that they are used to mount the actual hatch in place. So the only thing we have to do is just drill a couple holes here so we can then go ahead and put some screws in one of the formers to help hold the hatch in place. And that's about it. All right, friends, more to come. All right, friends, we are going to install the servos for the Canards. So let's talk about what our plan is here. We are going to be using the same exact servos that were used on the wing, and that is the high-tech D145SW thin wing servo. So here's the plan. As you can see, the servo is larger than the actual opening itself. And I do hope maybe in the future, if the manufacturer's watching this video, they might consider going through and opening up this area just a little bit so we can accommodate the entire servo. In the meantime, here's the plan. What we're going to do is we're going to cut off these 2 hold downs here, okay? And the reason why we're positioning the servo this way rather than cutting these 2 off here, which would bring the servo further back this way, is because we want to make sure there's adequate spacing between the actual servo arm here and the actual spar. So do keep that in mind. Now, once we've gone ahead and we've cut off those 2 hold downs, we're going to leave those 2 in place. We're then going to take our servo mounting tray that comes with the actual thin wing servo. We're going to cut this end off here and here. So this whole section is going to be gone, but we're going to keep this section here. Then we're going to go ahead, we're going to take our servo, we're going to place our servo in our actual hold down, okay, like so. We're going to use screws, pass them through here so it'll help to hold the servo down in. It's going to go down into the plywood piece, the plywood mounting piece here in the Canard, and that'll help hold the servo down. But that's not the only thing we're going to do. We're also going to use some double sticky back tape, and high-tech includes this double sticky back foam tape because with many of the thin wing servos, with the applications they're used in, say for example, maybe you have a glider with a thin wing, the wing might be so thin that you probably can't put any hold downs in there, and therefore the only way to hold the servo down is to use a very adhesive, high adhesive, double sticky back foam tape. So we'll have screws holding the servo in place and a double sticky back foam tape as well. So let's go ahead and get our servo mounted. More to come. All right, as we continue our update, let's talk about what we've got going on here. You can see we've got our servo hatch cover in place. And if you're wondering how we cut this, I kept the scraps from the plywood plate that was used here on the actual Canard. Remember, this plywood plate mounts between these two ribs here on the Canard, and that's what the servo is screwed into. So that's why we went ahead and kept this, because I just went ahead and traced this pattern out on plywood and was able to go ahead and use it here on the Canard. Now keep in mind, the plywood plate here for the Canard is smaller than the one for the wing. You're looking at the template for the wing, so do keep that in mind. So be careful, don't throw away your scraps. Hang on to them because you're going to need them so you can go ahead and make your servo hatch cover, because the servo hatch cover is not included in the kit. All right, let's talk about what we've got going on. First, we've got our servo hatch. We've got our opening here, which is just a little bit wider than the actual thickness of the servo arm itself. And as mentioned previously, we went ahead and we removed the servo hold downs here on the servo. We also trimmed off the opposite side of the mounting plate. And then we did go ahead and use some double sticky back tape on the bottom. Now, we're using number 2 servo screws, and I think they are 5/16. You don't want them too long. You want them long enough to go through the mounting, through the actual mounting plate into the plywood plate, but not so long as to punch out the other side of the sheeting. So keep that in mind when you're doing it. Outside of that, it's a perfect fit, works really well. Now we're going to put some hard points in. We're going to put a hard point over here and then a hard point here, and that'll help hold the plate in place. One of the great things about using the thin wing servo is that we can use this servo hatch cover, and it's a perfect fit. It's nice and flush with the actual Canard, which is a lot better than having to go through and use covering to cover up the opening for the actual servo. All right, friends, more to come. All right, we've got our hard points in place. Let's get our door mounted. All right, we've got our door in place, and you can see it works really well. And now let's get our horn in place. All right, our horn is in place, our push rod is in place, and we've sealed the gap between the elevator and the Canard, and you can see, works perfect. All right, let's go ahead and repeat the process for the right side. All right, friends, I thought we'd go ahead and do a little rolling test just to make sure that the nose wheel is nice and straight. One of the great things about this particular plane is that because we're only using one servo for the rudder, for steering, we can actually trim the airplane out simply by using the trim tab on the rudder stick. So here we go. Nice and straight. All right, folks, as we continue our update and working on an installation of the radio, what we're doing right now is we're actually working on setting the throws for the ailerons. And let me show you the tool that we're using. This is the Xicoy balance and weight meter. And not only does it do balance and measure the weight, it also does angles. You can purchase these little angle sensors separately with the meter. And the way you use them is they just get placed right on the actual control surface. You'll see here on the sensor, it says that there's this line, and you just take that line and you line it up with the hinge line like so, and of course tape it in place. And then once that's in place, when you move the surface, and we're shooting for about 13 millimeters, you can see it measures the surface. Pretty cool, huh? Very neat, very easy to use, and it really simplifies the measurement of the angle of whatever control surface you're working with. And it's especially good if you're setting up a 3D airplane, because it does have a very wide angle that you can achieve. And that's it. All right, friends, more to come.